Hey everyone, it's Advent of Code 2015, day 9. Today's Thursday, October 28th. Let's get started. Day 9. Alright, here we go. All in a single night. Every year, Santa manages to deliver all of his presents in a single night. This year, however, he has some new locations to visit. His elves have provided him the distances between every pair of locations. He can start and end at any 2 different locations he wants. But he must visit each location exactly once. What is the shortest distance he can travel to achieve this? For example, given the following distances: London to Dublin, 464, London to Belfast, 518, Dublin to Belfast, 141. Possible routes are therefore Dublin, London, Belfast, Dublin, London, Belfast, okay, yada da da da. The shortest of these is London, Dublin, Belfast at equals 605. And so the answer is 605 in this example. What is the distance of the shortest route? Okay, so we have our test case right here spelled out for us. I'm going to copy this. I'm going to create a test case. .text. I'm going to do like this. Expected output result. What's going on? Why is my do I have to go like this? Oh, it should be text, not test. There we go. Okay, now what? Expected result, expected output. See, that's what happens when you don't get autocomplete. There we go. Expected output is going to be 605. Okay, so given this input, what we have to do to accomplish this is we need to... So, I mean, this is kind of an interesting... they sort of give you the solution already. They just tell you to find every permutation of locations available and then, I guess, compute the distances between 2 locations. So let's take a look at our puzzle input. Oh, okay. This doesn't seem like a lot. So I'm going to assume that the puzzle doesn't say so explicitly, but this is bidirectional, right? So if I go from TriStream to Alpha Centauri, going backwards is the same distance. I think that's a fair assumption. And it looks like 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, 1. Okay, so this tells me that every pair of locations is accounted for. Okay, so I'm just going to go ahead and capture this in my puzzle input. 9. Why is that? Okay. I guess my number pad is not set up to work with this. Okay, yep, that's solved. Okay, so what we're going to do is we need to parse each pair. So I'm going to create a struct. I'm going to call it struct pair of, distance. What do we call it? Distance pair? Each line is going to represent a distance pair. And it's going to be, so let var location 1 is a string, var location 2 is a string. And just for, let's do init, location 1, string, and location 2, string. And then we're going to self.location 1, have to initialize it. Self.location 2 equals location 2. Okay, so let's create a function and say contains or includes one of these points. Location, string. So this just has to be a return location equals location 1 or location equals location 2. Func. So I want to create a equality operator. Oh, and we also need a distance, right? Var distance equals int. I'll add that to my initializer. Distance int. Actually, I have to say from location 1. Let's do this. From location 1 to location 2 distance. Self.distance equals distance. Okay, so that should be a nice API to work with. And then I want to say, what was I going to do? I want to add an equality operator. So I want to make this equatable, and this should offer to give me, oh, this has got to be a Boolean. I don't actually know if that function is going to be, it's going to come up, but we'll see. Okay, equatable. Oh, right, because it's sort of generating it for me, but I don't want to, what I want is a function that tells me whether or not this distance pair is equal for, like if location 1 and location 2 are reversed, I want this distance pair to come back up because it's the same. It's the same distance. So let's do this. Function equals is same as location 1, location 3, string, location 4, string, bool. Okay, so here's what I'm going to do. So guard location 3 does not equal location 4. So they have to be different locations, else return false. I'm just going to return false in that case because that's an invalid test case. Okay, so then and then return includes location 3 and includes location 4. Includes location 4. So what that's going to tell me is that, first of all, we need to make sure that location 3 and location 4 are not the same, because otherwise, if, let's say, Chicago is location 1 and New York is location 2, then Chicago, if someone puts is same as Chicago, it's not the same because, you know, it would otherwise evaluate the same. Okay, so that's how we're going to do it. They have to be different locations, and if they're both included here, then it's the same. Okay, so with that, I need to parse the input, and so we need to, so that's my first initializer, so let's also do init descriptor. So string, so from this, okay, they all are one-word names, so that makes things a little bit easier. Let's open debugx.com. because I'm going to have to write a regular expression to parse this. Luckily, it should not be difficult to parse. Oops. Okay, so first we have a show cheat sheet. First, we're going to have a word boundary. I don't know what that is. Okay, a word character. One of any character. Blah, 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 blah. Okay, so let's just do, it's got to be A to Z or A to Z, and there's going to be multiple of those, and there's going to be a space, and then there's going to be the word to, and another space, and then we're going to do A to Z again. I'm going to do this, and these have to be capturing groups because we actually need to know what the names are. It should be a fairly straightforward regular expression. Equals, and then digits. Plus. Okay, so we have group 1 is a repeating group of words to another word equals a number. So that should be very simple. Let's do this. We're going to do let groups equals regex parse. There's my string. I don't think I need to escape anything. I don't have any. Oh, I do have to escape this \d, but that's the only thing. And then we just have to parse the descriptor, put that in there, and then we're going to do self.location1 equals groups 1, 0, self.location2 equals groups 2, 1, oops, 1, and self.distance equals int of group 2. And I'm going to give that a unsafely unwrapped because I'm fairly confident. Actually, all of these. Let's do that. Okay, build succeeded. Good. So now I can go up here and I can say parse my input.lines.map distance pair.init descriptor. So that should return my distance pairs. Now I just need to come up with all the permutations. Do I have a function to come up with permutations? I don't think I do. Permutations. Okay. How am I... No, I don't want permutations of the distance pairs. I want permutations of the locations. So then we need to get all the locations. So if I simply I have an idea. So I want to create a var, a computed var called var locations, and that's going to be a set of strings, and it's going to return a set of location 1 comma location 2. So then all I have to do is roll those back. What do you mean no exact matches and call to initializer? Oh, do I need to wrap this in an array or something? Yeah, okay, fine, that's whatever. Okay, so we're going to, now we have this location set, so I need to go through all the distance pairs, get the locations, and combine them into one set. So, distance pairs dot, locations, distance pairs dot reduce. Yes, reduce. And we're going to start with an empty set of string, and we have the new result is existing set and distance pair. And we're going to return existing set dot including intersection, no, subtracting union of the other pair dot locations. There we go. And then let all locations. Okay, so, and then from all the locations, we need to come up with a list of permutations. All locations dot permutations, no, dot, okay, I'm gonna go ahead and Google this. Swift permutations of a set. Permutation, Swift algorithm. Okay, ABCDE. Here's another permutation. Okay. Func permutations. I don't know. I just want it to generate the generating the permutations. Here we go. So far we've counted how many. Okay, here's recursive by Nicholas. Okay, the worth permutation algorithm. Display the current if n equals 0. Display the current permutation. Else. Okay. We have a, no, actually this is going to be a set of t. Well, I guess it can be an array. That's fine. We'll just turn it into an array when we pass it in. And what is n? Oh, n is the index. Okay, we actually have to pass the index in. So I guess if we're doing permanent worth, we'll pass 0 in, and then, oh, I call recursively. Oh, and it, oh, I see. No. N minus 1. No, n has got to be the count. Okay. Let all permutations equals all locations. No, permute worth. This will be all locations dot array shuffled. That'd be funny. I don't want to do that. I don't want to shuffle it. I just want it as an array, sorted. Oh, that's good. And then all locations dot count. Okay. All permutations. So then for each permutation, we want to compute the total distance from all the locations. So all locations, distance pairs can't. Okay, okay. And then for each. Okay, so we're gonna have to do. In an earlier puzzle, I did this thing where I need to create each pair. Distance for permutation. That's what I need. Can I int type argument type int? What? Oh. Okay, this is a badly written algorithm. It's not it's not syntactically correct. Let's see if I can find another one. Calculate all permutations of a string in Swift. Okay, I don't want it as a string, though. An array of string. All right, I'm just going to take this person's. I'm going to take this person's code. Collection, items. Yeah, okay. C, collection, items, C. Perfect. So it actually, this one will work for a set beautifully. Okay, so this is going to be permute. And it's going to be all locations. Actually, I don't even need. All right, that's how it works, right? Oh, no, I need to name it items. There we go. And now for the permutations, I need to create pairs. So I'm going to create a function called make pairs. Function make pairs, make connected pairs. And of an array item of, items. And that's going to be C. Oops. I do need to be C. Let's just make it T. An array of T, and that's going to be an array of T. An array of T. Right? So we're going to start with items dot enumerated, and we're going to do compact map, and we're going to say E I, right? Because we need an enumerator, we need the element and the index. And I think it's index first. Yeah, index is first. And element, E. E is for element. Okay, so we're going to say guard I is greater than 0, else return no. This is going to return a T. No, it's going to turn an array of T like this. And otherwise, we're going to say return items I minus 1, comma, E. Right? So let previous item equals items I minus 1, and then previous item. That should build successfully. Build succeeded. Okay, good. So make connected pairs. So from all permutations, we're going to do all permutations dot for each. We're going to create a connected pairs. So, okay, for the permutation, we're going to do let. Actually, I want a function called. I need a class, and this class is going to be called. See, I feel like I'm missing something. I need some sort of planner object. So we're going to do a trip planner. Okay, and the trip planner is going to take a set of distance pairs, or I guess an array of distance pairs, right? Because that's what I actually have. Yeah. Okay. Var distance pairs, and it's going to be an array of distance pair, and in it, distance pairs. Distances is an array of distance pair, and self dot distance pairs equals distances. And then we want to find a function compute shortest route. And that is going to be, it's going to return an array of string, because that's what and it's going to return an array of locations. And, and it's also going to return an array of string and also the distance between them, right? The actual puzzle only cares about the distance of the shortest route, but I feel like this is probably going to be useful if we actually have that data handy. And we'll just have it in memory, so there's no reason not to return it. Okay, compute shortest route. So from the distance pairs, So we want to distance pairs all locations. Let's do this, all locations, and we want let all permutations. Okay, and then all permutations for each. We're gonna need some helper functions. So we're gonna say let pairs equals, or no, compute distance. Ooh, actually, I have a better idea. Compute distance for root, right? And the root is going to be actually compute distance for root is a better way of spelling that. Compute distance for root, and the root is going to be an array of locations. That's going to return distance. It's going to return that. Okay, so now that we have, so how do we do this? So now we need to create the pairs, make connected pairs. Okay, so we have our root, and we're going to say let pairs equals root make connected pairs for root. So this should give us, you know, like first one, look at second one, third one, fourth one, so on. And we're going to say func get distance for connection. And it's going to be location 1 is a string. Location 2 is a string. Get distance for connection, location 1, location 2. And that's going to return an int. And this should be memoized, right? I feel like, well, let's go with this for now. This is something that we could cache if we needed to, because otherwise we're going to be looping through this distance pairs over and over and over again. Granted, it's not a very big array. So, you know, I don't even know, it's not that many, right? I mean, I can fit it on one screen. So maybe that won't be such a big deal, but let's see what happens. Okay, so we want to distance pairs dot find, first where the pair dot is same as, right? Is same as location 1, location 2, right? That's what we want to find. Let pair equals distance, okay? And it's going to return pair dot distance, right? Okay, make connected pairs. Cannot be used in an instance of nested. Oh, okay. Well, that's fine. I'll just move this into my class, my planner class. Okay. Oh, and the permute is also got to be moved into my planner class. Okay. Yep, it's not returning anything, but that's okay. We haven't gotten that far yet. Compute distance for root. So we have our pairs, and then from our pairs, we need to let distances equals pairs dot map get distance for connection, and it's going to be 0 the first item, and then 0 the second item. So it's going to take my little array pair, and it's going to get the first item and the second item, and it's going to return the distance for that location. That's going to be distances, and get distance from location, and then the total distance is going to be return distances dot reduce. So we're going to start with 0, and we're going to add them up. That'll create a sum and all permutations, and we're going to do all. So then we want to find return. Okay, computed distance. Let all permutations with distance equals all permutations, and we're going to map it. We have permutation, and from the permutation, I'm going to say let distance equals compute distance for permutation, and we're going to return the permutation. We're going to return a tuple, the permutation with the distance. Okay, and then from that, we're going to return minimum. No. Is there a minimum where? I don't have a minimum where. Okay, so let's return. I guess it's got to be a reducer, right? So all permutations with distance dot reduce. I'm going to start with all permutations with distance. I'm going to start with the first item, right? And here's what we're going to do. We have our result. Yeah, let's just do R. And then we have the tuple. And then if the tuple, and we're going to return if R dot distance. No. Oh, yeah, R. So is a tuple. So R is going to be a tuple. So the first item in the tuple is permutation. The second item in the tuple is different distance. So index 0 is permutation. Index 1 is distance. So if R dot 1 is less than tuple dot 1, we're going to return R. Otherwise, return tuple. Unable to infer complex return type. Okay. What do you mean? Okay, let's just see where it wants to put that. Yeah. Oh, is the word tuple a reserved word? It might be, it is. T. Okay. And it's going to return a string int. Oh, okay. I feel like I almost need to like name this tuple. Oh, this has got to be t.1. The word tuple is throwing it off because it might be a reserved word. Okay, so we're going to find, this is going to return the shortest root as it's going to give me the root and also the distance. So distance pairs, okay, and then we're going to find, so we have trip lat planner equals trip planner, and we have our distance pairs, distances, distance pairs, and then we're going to say shortest root equals planner dot compute shortest root, and we're going to return shortest root dot 1, which is the distance. Okay, make sure it compiles. Okay, it does. Where's my terminal? Here we go. All right, let's see if it works. Okay, test cases pass. Solving A. 251. Submit. Good. We're 1 gold star. Okay, continue to part 2. The next year, just to show off, Santa decides to take the route with the longest distance instead. He could still start in it at any 2 different locations he wants, and he still must visit each location exactly once. For example, given the distance above, the longest route would be 982 via, for example, Dublin, London, Belfast. What is the distance of the longest route? Okay, so now test case B is going to be the 982. Okay, and the way we're going to solve this, we have our trip planner. So now instead of compute shortest route, func compute longest route. String int. And so we're going to do this. And then all we need to do is this. If the previous result is longer than the new result, then return R. Otherwise, we're going to return the shortest. I could refactor this to make it simpler, but just in the interest of time, what we are going to do is I'm going to do this very quickly. Compute longest route. All right, this should be, hopefully this is all I need to do, and there's no gotchas. Solving A, 251. Solving B, 898. Beautiful. Oh, beautiful. That was a record-breaking part 2. All right. That was actually very easy compared to the last couple days, which tripped me up. Those regular expressions really tripped me up. This one had simple regular expressions, just dealing with sets and stuff like that. There are a lot of performance optimizations I could do here. For example, I could maybe, like this thing, this trip planner, I could refactor. A lot of this is duplicated code. All of that stuff could probably be reused. I could also capture we could also cache the distances. So if we keyed this, so a distance pair, if we made that a set, then it might be easier to like locate the distances and look them up and stuff like that. We could improve the performance quite a bit. But it's, you know, a small puzzle input. I mean, if they had really scaled it up, it could have been nasty, but luckily we didn't have that. All right, so I think that'll do it. I'll go ahead and commit my code. 2015, day 9, solved. All right, with that, we can return to my advent calendar, working our way up the tree. Yeah, sounds good. I'll see you all tomorrow. That was fun.